Hey, hello everybody. It's Mr. Kinney here. Oh, I think this is like day 53 of our shelter in place. So anyway, hi. We're going to go over molarity by dilution. And previously we went over the idea that molarity, which is a capital M, let me scoot this down, is equal to the number of moles you have of a chemical divided by how many liters you have of that chemical. So we worked through that before. And we use this a lot when we're mixing up various chemicals, especially liquid chemicals. And we're about to start the acid and base unit. I would be preparing a lot of acids from dry materials, and I'd calculate how many moles I'd need to make 1 liter. Then I'd convert those number of moles into grams, and then I'd go measure that out and mix it up. Once you've got, though, a liquid made up, you can dilute that down to whatever you need for your lab. Now, a great example of what we're going to do here with this diluting. Now, dilution means you're going from something that's really strong or concentrated to make something that's going to be a little bit bigger, but not quite as concentrated. And a great example of this is if you buy some orange juice, frozen orange juice, frozen. That's supposed to be frozen, that's OJ. And usually what the directions say is that you open up this can and then you put it into a big pitcher. That's a terrible pitcher, sorry. Okay. But you're going to put this little bit of stuff into here. Okay, so it goes into there. But then you fill the can with like 3 cups of water, 3 containers of water. So you add more water, more water, more water. And this really concentrated, which I'll draw in dark now, almost liquid, sugary material kind of gets diluted into here. So it's not quite as strong, and it's usually a much larger volume. So what we might say over here is that our original volume was just 1 can. Over here, our volume is going to be, well, we've got 4 cans because if we've added 3 containers of water plus this, our volume is now 4. We've increased it by 4. If our molarity, let's say our molarity was just 1 over here, we had a 1 molar solution of this sugar material. Well, what's going to happen is, since we have made this much more dilute, what's going to be the molarity over here? And you can probably figure it's probably about 1/4. So there's a rule that we have for that we use all the time for working with that, and we use this relationship right here. The starting molarity times the starting volume. In our case here, like we had a 1 molar solution, let's say, and we had a volume of 1 can. It'll be equal to the new molarity, okay, much lower, times the new volume. We said the volume is 4 times bigger. So if we use this rule here, M1V1 equals molarity 2, the new molarity times the new volume, those are going to be equal to each other when we multiply them. So we're trying to find the new molarity in this little example. We know the volume is 4. I'm going to put I'll make this an X, okay? So it's kind of like more like an algebra problem. And we know that X times 4 is going to be equal to our starting molarity, which we said was 1 molar, times, and we had a volume of 1 can. So we want to get X all together over here. We want to rearrange the equation. So I'm going to divide both sides by 4. Now that would have been 4, oh, that was a volume right there, right? So I'll put V there. So the 4's cancel out. And over here, we have to divide this by 4. And take a look, 1/4, 0.25. Our new molarity here, we figured it would be 1/4, will be 0.25 molar. 0.25 is the decimal equivalent of this. So that's what we're working with here. And we're going to do a couple practice problems. I didn't want to give you the full sheet that they're doing because we want to get you into the next unit here. So we'll do some practice problems here. Just want you to understand that when you have a liquid supply of some chemical, we can use this equation to dilute it down. Usually for us, it's really strong hydrochloric acid, and I dilute it down to a safe level for us to use in the class. So, oh yeah, molarity. Yeah. Okay, here you go. All right, let's see. If you get 1 liter of water Okay, and then you go to your dentist and they pull out your wisdom tooth and they drop one of your molars in there. Okay, what do you now have? Okay, that's supposed to be your molar. Yeah, you got a 1 molar solution. Ha ha ha. Okay, here we go. Enough comedy jokes. Let's read through the problem here. How many, oh, by the way, normally the volume is going to be liters that we use. But if we were just doing straight dilutions, if they give us milliliters, that's okay, as long as we know that both sides would have to be milliliters. And we're not going to give you any tricky questions like that. So let's read through the problem. And instead of you writing that all out, we're looking for how many milliliters of an aqueous, that just means dissolved in water, 2 molar solution. Okay, well, that's a molarity. And since they're asking how much of this, let's continue on, must be diluted to prepare. Okay, so what we're preparing, this is going to be our new volume. So whatever we're making, that's going to be volume 2. And let's see, I don't know if I could zoom in. I'm just going to leave this here. And this is going to be molarity 2. This is our new molarity. And that would mean that this would have to be molarity 1, what we're starting with. So how many milliliters? We're looking for volume 1 is what we're trying to find. So let's write our base equation. M1 times volume 1 is going to equal the new molarity, it'll be lower, times the new volume, which will be bigger. And let's just substitute in now. Oh, we said we're looking for V1, so we're looking for that one. I'm just going to go ahead right now, mathematically, cancel that out. I have to divide this side by M1. Okay, now I'm just going to substitute. The molarity 2, here's molarity 2, 0.4 molar, times the new volume, we wanted 100 milliliters. Okay, and we got to divide that by, we figured out we need to divide that by the starting molarity, which was 2 molar. Okay, got that set up. And let's see here. Going to put this in the calculator. We got 0.4 times 100, and I'm going to divide that by 2 equal, oh wait, I did something wrong, something went wrong there. 0.4 times 100 equals, divided by 2 equals, okay, there we go, equals 20, okay, the molarities canceled out, milliliters. So what that means is we would have had to taken 20 milliliters of this stronger solution, and we were going to we'll put that 20 milliliters in a container, and then we would fill that container up to 100 milliliters to end up getting our final solution. So 20 milliliters is the volume we need to start with. Okay, for the second problem here, how many milliliters of a solution of a 0.4 solution of potassium iodide are needed to prepare this? Okay, so we're preparing this. This is our new stuff. See how we're starting more concentrated here, less concentrated there? The less concentration is always going to be our new one, molarity 2. This is going to be our volume because we want 250 milliliters of that. And that means this is molarity 1. How many milliliters? Okay, we're looking, it's kind of set up just like that problem, just different numbers. And that's going to be volume 1. So our base equation, M1 times V1, will equal the new molarity times the new volume. And you know what? It's the same equation here. I'm just going to go ahead and take what we did there and put that over here. When we rearrange it, we need molarity 2 times volume 2 divided by molarity 1. Molarity 2 in this problem, we said, is the less dilute 0.76 molar solution of potassium iodide. We got to multiply that by the new volume we want. So the new volume is going to be bigger than what we started with. And we got to divide that by our starting molarity, which was 4. Okay, so let's see here. Now the molarities cancel out. Our answer will be in milliliters. And let's see here. Let's go 0.76 times 250 equals that. Got to divide that by 4 equals, and 47.5. And I already did this before, so I'm not, normally I'd ask you to double check your calculations, but I've already double done that. So here's what you're going to work on for this assignment. You are going to do these problems right here, and they're on Google Classroom, so you can upload that and just set them up just like I've done there. And then I'm also going to have you record the notes that follow this that are going to be on other types of concentration. So notes on concentration. So what you'll turn into me will be a picture of this page here. You can do this in your notebook and your notes on, well, actually, I'll have you turn in this whole thing. These notes here, this problem, and the notes on concentration. So, bye.